Hello and welcome to my video on Aspergillus ORYZAE and how it can be applied to the industry of biotechnology. Let's begin. Prior to the making of this video, there were two experiments that were carried out. One was about examining the growth of Aspergillus ORYZAE using varying concentrations of glucose in agar, while the other one was about examining the effects of antibiotics on the Aspergillus ORYZAE. From the results and statistical analysis, it was able to be determined that the higher the concentration of glucose, the larger the amount of Aspergillus ORYZAE would cultivate and grow. This is because the agar plate containing 5% glucose had a larger amount of Aspergillus ORYZAE growth as compared to the plates with 4%, 2% and 1% glucose. Also, the areas of inhibition between both agar plates did not cover a large amount of the area of growth in the agar plates because the antibiotics became ineffective as its use had expired. This is why, when the sum of the areas of inhibition for both tetraglycine and streptomycin were subtracted from the total area of the agar plates, there was still an area difference of 40.97 centimeters squared and an area difference of 49.46 centimeters squared when the sum of sulfurylazole and penicillin was subtracted from the total area of the agar plates. Due to genetic engineering, the development of Aspergillus ORYZAE by large-scale industries has developed with an even greater efficiency to produce foods, enzymes, and pharmaceuticals. This is due to the following: a relatively large genome size. Yeast cells produce functional eukaryotic proteins. Homologous and heterologous proteins use filamentous fungi as hosts for their production and protein synthesis. Aspergillus ORYZAE can be used for fermentation industries. Industrial uses in food industry include alcoholic beverages, miso, and soy sauce. Additionally, Aspergillus ORYZAE is used to produce food-grade enzymes. Ground soybean and wheat grains degraded by proteases and amylases produced by Aspergillus ORYZAE conidiospores are sprinkled on their surface, which breaks down proteins to peptides and starch into maltose and glucose. This results in the production of soy sauce. It is classed as safe to use in the food industry as a grass fungi, which is generally recognized as safe. It is supported by the Food and Agriculture Organization of the United Nations in 2019. There are two types of cultivation of Aspergillus ORYZAE which could be used for different purposes, being solid-state cultivation and liquid cultivation. Solid-state cultivation allows Aspergillus ORYZAE to enhance protein production. It enhances amylase, lipase, and protein enzyme production, which is useful in the industrial production of enzymes. Its processes are possible because of the high level of expression in Aspergillus ORYZAE. It is useful in both fermentation industries and in modern biotechnology. Liquid cultivation increases the efficiency of enzyme production in the industrial scale. It has a long history of safety in enzyme production. It is able to produce a large variety and number of metabolites. It is considered an excellent host for the safe production of industrial products. Genome research uses a production of enzymes, chemicals, and new industrial processes. The reductive amines is when in 2017 the University of both Manchester and York, with their researchers, had been able to find a new enzyme found in Aspergillus ORYZAE. This helped synthesize chiral amines, which are used in the production of pharmaceuticals. which could have helped improve the production of new Parkinson's disease treatment with a monoamine oxidase inhibitors class. Other types of fungi are useful in producing antibiotics, such as the penicillin. There are 4 phases which affect the cultivation of microbial products. The lag phase, which is when once the organism is inoculated into the growth medium, they need time to adjust to their new conditions to allow them to become more active and in turn be able to synthesize enzymes. There is little to no reproduction of cells at this stage. The log phase during this is when the rapid growth of cells occurs as organisms reproduce. The growth continues until the organisms have taken up most of the available nutrients, space, and oxygen, and toxic waste levels are not elevated. The stationary phase is when once all the available nutrients, space, and oxygen begin to run out, and as the toxic waste levels begin to poison the organisms, the rate of growth and cell division becomes equal to the death rate. This results in no additional multiplication of the organism. The death phase exceeds their production rate as all nutrients, space, and oxygen supply have run out. The toxic waste levels are very elevated here. As mentioned previously, Aspergillus ORYZAE can be used for fermentation industries. There are 2 forms to this: batch fermentation and continuous fermentation. Batch fermentation is a closed system where Aspergillus ORYZAE is inoculated and grown in a nutrient medium with a fermenter. No further substances or nutrient medium is added to or removed from the fermentation vessel throughout the log phase. Waste gases are released through vents. Once the growth cycle is complete, the contents are drained out and the product is separated from the mixture. When the fermenter is fully cleaned, it should be ready for another batch. In the event of a culture becoming contaminated, only one batch is lost, which means that there is less financial loss. It is easy to set up and monitor the growth and factors that affect the growth, and vessels can be used for different products at different times. Continuous fermentation is an open system where there is a continuous feed of concentrated growth limiting substance and sterile nutrient solution added alongside an equivalent volume of the converted nutrient solution containing the Aspergillus ORYZAE being extracted. There is a steady growth which is maintained by adjusting levels of nutrients to ensure the optimum growth level and maximum yield of the product in the least time. It prevents the buildup of byproducts. It has a higher volumetric productivity of products. The Aspergillus ORYZAE is maintained in a log phase. Smaller vessels can be used. A more productive and cost-effective process is being handled here. It is difficult to monitor the system and microbial cells may clump and block inlets. There is a huge financial loss if something goes wrong, and there is an increased likelihood of foaming, so an anti-foaming agent is required in the mixture. Here are the references of which I have used. Thank you for watching.